With the reactive force field ReaxFF, reactions in complex chemical mixtures totaling hundreds of thousands of atoms can be modeled on a modern desktop computer. Now ReaxFF has been extended to allow for the simulation of explicit electrons. With these explicit electrons, new doors will open for the simulation of redox reactions, in particular those found in lithium batteries. The new eReaxFF is included in the Amsterdam modeling suite, and now the first tutorial has become available online. The new tutorial walks you through the process of setting up and running a simple electron transfer reaction. The reaction itself is taken from the first eReaxFF publication and consists of an excited anion that relaxes into a primary carbon ion. Much like in standard ReaxFF simulations, the atomistic structure and settings, such as the temperature, are easily defined in the graphical user interface. What's new is the addition of an explicit electron particle. This particle is placed just like any other atom in the simulation. The presence of the electron and the choice of a specific parameter set will automatically activate eReaxFF. So after saving, one can start the calculation and follow the relaxation dynamics in the graphical user interface. The electron diffuses rather effortlessly through the conjugated chain, while the intersection between the aliphatic and conjugated part is a point with slightly higher stability and hence a higher degree of localization. Eventually, the electron will be able to escape the small well at the intersection region and diffuse to the radical side. The arrival at the radical side is clearly visible, also as a drop in the total energy of the system. From this simple simulation, further insight into the temperature dependence or more detailed analysis of the relaxation dynamics are straightforward.